How do chatbots like ChatGPT or Claude take data from other places, like documents or databases, and make use of it to answer questions? So my name is Shay Brown. I'm the CEO of a company that audits algorithms. I'm also a professor of astrophysics for 11 years. And I also run a community and educate people on artificial intelligence, specifically for AI auditing, but just also people who are curious about AI and how it works. So some of these concepts can get a little complicated, and it's often difficult to explain things from end to end for what is a large language model, how is it trained, to how does it do complex things, particularly sort of agents or agentic workflows, and a lot of the things that people are talking about now. And so I've started a series of sort of deep dives into exploring this. The last one I did, which I'll post it somewhere here, I talked about the real basics of large language models. Like what are they? How are they trained in general? What is it to predict the next word, and how then do you generate words after that? And my ultimate goal is to get to the point where we can understand enough that we can start talking about agents and agentic systems. So today I want to talk about sort of the concept of getting information from someplace else and put it into the large language model so that it can do something with it. And so to do this, we have to understand things like the context window that the large language model has access to, things like retrieval-augmented generation, in-context learning, those sorts of things. And so let's dive into it and try to figure out at a high level, how do some of these pieces connect together so that I can understand when I upload a PDF to ChatGPT, how is it that it's giving me answers related to that? So the first place I want to talk about this is the same notebook that I used in my last example. So I have a notebook here which has a very simple transformer decoder kind of architecture laid out. And so if you haven't watched the previous video, please go back and watch that so you can understand what some of these pieces are. But in essence, to sort of sum up what I talked about last time, these chat models are really, at the base of them, there's this model in gray here, which it's a bunch of mathematics. And so I'm going to type in a prompt. That prompt is a bunch of letters. It's going to get tokenized into numbers. Those numbers will get embedded, get turned into a big list of numbers called embedding vectors. And then there's going to be some mathematics, which I skipped in the last talking about, attention. This is called a sort of a transformer. Don't worry about that. But basically what happens at the other end is I have a probability distribution for the next token. So somehow I'm going to come up with a way of selecting the next token. Then I'm going to essentially append that to the prompt, and I'm going to feed it into the new prompt. And I'm going to sort of generate new words from that prompt. And there's a lot of training that goes involved there. So now the question, we want to zoom in a little bit and understand how does this work? So it was trained on the whole internet. We talked about supervised fine-tuning last lecture, and some of the details about how you get this thing to behave like a nice, helpful chatbot. So in order to understand how does it make use of information that's external to it, we have to talk a little bit about what happens, the mechanics of what happens here when the prompt. So one thing that I didn't talk about is that there's sort of a fixed window of information that I can put in here. Now, there's a lot of work being done in this area, and some of what I say will not apply to every single large language model, but for the most part, there is something called a context window. Context window, and the idea of context is a good one to understand. We're talking about the context is what's coming into the large language model. So the text that I'm feeding it before it starts to generate some more text. Okay, so the context window basically is like a fixed size of information. So it might be some number of tokens. So there's like a long window, and it's like a bunch of slots where I can stick tokens. Now tokens here mean, you can think words, you can think sort of partial words, and there are all sorts of different kinds of tokens, but it's actually kind of a fixed size. And this is because of the nature of the way these mathematics in here works. It has to be a fixed size. I have to feed something that is the same length every time, and then the math is going to proceed, and it's going to spit something out, which is also a fixed size. So if I go back up here to this next token distribution, it is going to be a distribution if you remember from the last lecture, over the probability of the next word. And so I might select a particular token here, and I'm going to append that token to the prompt. This is a fixed size as well. And so the input is fixed size, the output is fixed size, and I can keep sort of progressing from there. So you might wonder, well, what happens if it's a fixed size? What happens when I just give it a couple of words, like tell me a story or something? Well, if this is the beginning of this context window, where this is think of this as just like the bucket where I can put my tokens. If I just say, tell me a story, what's going to happen is I'm going to put those tokens for tell me a story right in the beginning. And then everything else here, I'm going to pad it with just something like zeros. There's different ways of padding this extra information, but I'm basically going to put no information in here. I'm just going to stick all the information in here. And so then what it's going to try to do is try to predict what's the word after, what's the next word that I should have. Maybe I should point the arrow in a different direction. So if this is tell me a story, then it's going to try to predict the next word, like a story you might like is, and then it's going to generate some sort of story. And so every time it gets added on, every time a new token gets added on as it's generating, it gets appended to this list. And so every time it gets fed back in, it's filling up this context window. And it just keeps going and going. But at some point, it kind of runs out. Now, there are different techniques for sort of wrapping this context window where you can kind of fold it over and try to cram more information into each slot than is sort of meant to be there. But let's ignore that for a second. That's something that people are still working on, and it's still sort of an unsolved problem how to do that optimally. I'm sure we're going to make improvements. But the point is, there's sort of limited amount of information, and it has to be sort of this size of the context window. Okay, so why is this relevant? So let's think about how the large language model is getting and giving you information. It's basically getting information from all of these weights inside the large language model. So those weights, or the numbers from inside the large language model, came from the training. So it's basically getting information from the data it was trained on in order to respond to your prompt. And so in some sense, it has encoded within it a sort of a base of knowledge, right? But obviously, when I start typing things out, it's somehow getting information from my prompt. So I give it some information in the prompt that says, maybe it's like, I run a social media company and I need to promote my services, and these are my services, and I want to have a beautiful ad copy talking about my services, right? It's going to start generating that ad copy for you, but it didn't have that ad copy or those, within its weights. It's somehow learning from the context that you give it in this context window. And so this is something that's called in-context learning. I spell very well. So it's in-context learning. It's learning from the information you give it. So this is something that as soon as we started playing, we meaning sort of like general public, let's say, was playing with chat models, immediately that was the amazing thing that we realized, that it's like understanding, so to speak, what I'm giving it, and it's being able to produce output that is tailored to my prompt. So this in-context learning is still something that we're working to understand. And so in essence, the words that you give it will affect the likelihood of certain words being put out at the other end. And so if I start talking about ad copy, or I have a social media company, it's going to start drawing and increasing the probability that the output is going to be related to those things. And so even though the model itself, after it's been trained, is fixed, those weights are fixed, it's not learning as it goes, it will learn from, in some sense, how to draw that information and assemble that information based on the context. So it's not really learning in the way that I talked about in the last lecture. It's just kind of learning how to draw information from the context. There's no changing of the weights here. So this is called in-context learning. And importantly, it all has to fit within this context window. And so the prompt that I give it, it's got to fit in this context window. And if it doesn't, it starts forgetting things, basically. Things start spilling out over the edges, and it can't fit that information in. So there's a limited space. There are these wrapping techniques and different ways you can try to cram more information in there, but still it is limited inherently. You can't put every piece of information into that context window for it to learn. So now the question is, how do I deal with cases where I have a lot of information that I want to learn and query and get information from? How does that work? Like I upload a PDF. So let's say I do exactly that. I upload a PDF into my chatbot. So let's say that that PDF is really short. There's not very much text. So what's going to happen is the interface that I uploaded, it's going to grab that information. Now, if that information can just fit into the context window, so if I say something like, if I just say summarize this document, and that's my first few tokens, and if I can fit that whole document into this context window, then you might as well just cram the whole document into the context window, and it will understand, I'll put that in quotes, it will try to summarize what's in here because it has access now to all of that document because it's getting, it's going through the whole system. So it has access to all those tokens to give me more information out the other end, to give me generate more text. However, what happens if the document is too big? So if the document ends up being too big, then it has to find some way of dealing with this. And so I'm going to go to a lecture here that is, let me see if I can find. I'll just go here. And so what it will have to do is it's going to have to do some searching here. And oftentimes, or almost every time, it's going to use something called retrieval-augmented generation. So this might be something that a lot of you already know about. So I'm talking to those of you who don't understand how this works. So the way this works is going to rely on embeddings. So I talked about embeddings before. And so as a reminder, what an embedding is basically a long list of numbers. This is supposed to be like a little long matrix, and I have a number here, a number here. I call this in physics a vector, but you can call it whatever you'd like. It's just a column 1D array. It's just a list of numbers. So the embeddings I talked about before basically were talking about individual tokens. So I was talking about, you can represent these numbers as these embeddings as arrows in a certain space. And the arrow that is a cat might be next to an arrow that's kitty. That's my favorite example. And dog and puppy might be close by each other. So these arrows or these embeddings sort of represent some meaning of these things, these individual tokens. But now we're going to talk about a slightly different sense of embedding. It's actually the same sense. I take that back. It's not that much different. But what we're going to do is we're going to embed it more tokens together. So it's like sentence or paragraph level embedding. So there are different ways of doing that. And I don't want you to focus on the different ways that you could do it, but just know that you can take many tokens. So the dumbest thing would be if I have a paragraph, I just add up all the tokens in that paragraph, the embeddings for that token in that paragraph, and I can get another embedding which sort of somehow captures the meaning of all of those tokens together. There are different methods for doing this, but let's just assume that for a minute that you can do that. So now what happens is if I take a prompt, so let's say I've uploaded my PDF, what it will do, it will sort of chunk it up into different chunks of text. So here are like little document chunks. These are chunks from my document. And it's going to take those chunks, which are just lists of, or just, natural language, a sentence, a paragraph, something like this. It's going to tokenize all of those tokens, and it's going to embed all of those tokens from that paragraph chunk into a vector, into one of these embeddings. And so similar to having cat and kitty, and it's going to do the same thing for all of these chunks. So now I have these embeddings, which are vectors, which represent the meaning of that chunk of text. And so let's say I want to talk to my chatbot, and I'm going to say, I'm interested in understanding some piece of information out of that document, right? So tell me what this document says about my right to employment. Let's say it's a legal document or something like that. So it's going to tokenize that, and it's also going to embed that. Now this tokenizer and this embedder is going to be the same tokenizer and embedder that I use for the document chunks. And it's not necessarily the same tokenizer and embedder that I use for the chat model that I explained before. It could be a totally separate one. I could just go out and find some model that will give me a nice embedding for a sentence or at the paragraph level, and I get these vectors. And so now I have this sort of vector, which is like a representation of the meaning of that thing I just asked. And then I also have a bunch of arrows, and I'm drawing them sort of slightly different directions here because the direction in this space kind of encodes the meaning. So these different chunks have different directions because they have different meanings. They're different vectors. And then I'm going to do something very silly and simple, a similarity search. And what is that? I'm just going to take this vector and I'm going to put it next to my prompt vector. And I'm going to like measure how far away is that vector from this vector. And there's a bunch of different metrics. Cosine similarity is one of them. There's all sorts of ways. But it's going to measure kind of how close is this to that. And I'll take this next one and it's going to be off to this side like that. And this one might actually be it's even closer. And then I'll take this one, which is over here, kind of off in that direction. That's pretty far away. And so when I do that, I say, oh, you know what? This one here, this is actually pretty close. So, and what the closeness means here is that somehow it has a similar meaning or it's related to the same thing. And so because I can't take the whole document and just stick it into my context window, what I'll do is I'll say, hey, I want this chunk of the document. So I'm going to take this and I'm going to stick it and add it onto my prompt. So I'm going to have my prompt that I asked originally, and then I'm going to add in those text chunks. Now, whether it adds it in as a embedding or it just grabs the text chunks and puts it in the actual text and adds it on, doesn't matter. You could do it kind of two different ways if you wanted, but at the end of the day, it's adding in that piece of the text. So now I'm going to ask it about a thing, a particular topic, and I'm going to add some context so that this chat model now knows in quotes about what this document has to say about that. And so this is what's called retrieval-augmented generation. And there are all sorts of different ways you could do this. You can add, you might grab multiple chunks, which is almost always you will. You can maybe iterate through how this searching goes to try to find you can use different metrics and to prioritize different chunks of text. You can add metadata. So you could just add the chunk of text and give it to it, but it won't know where you got that information from. So I might add some metadata saying, oh, this is from page 5, paragraph 2. And so you can put references in there. And so that's where a lot of the development work, people trying to use this for in their products, are doing these sorts of things, trying to get retrieval augmented generation to let me query information from the outside world. So when in my last video, I talked about the fact that some of these systems can also query the internet. And at a very basic level, it works pretty much the same way. And so this is an example of sort of tool use. No, let me go back. This is an example of tool use. So I promise that not today, but I promise that the next video I'm going to get to agents. And this is the use of tools is one of the features of an agent, one of them. And so if I'm in a GPT, ChatGPT using 4.0 or something like that, and I ask a question, it can elect to go and search the web. So it's going to search the internet. And what it's going to do, it can do it in a bunch of different ways, but it can basically generate from my prompt a good query and maybe use Google or something or some other way to search. But it's going to generate a query. It's going to search the web, probably using just standard search algorithms. And this is changing how those search algorithms work. But at the end of the day, it's going to return a bunch of results, web pages. And what will happen is those web pages are going to have text in them. And you guessed it, it's going to chunk it up. And it's going to take that text and embed it, and it's going to do the exact same thing we did before. It's going to take a similarity search. It's going to say which chunks of this text from that query, from those websites, is going to be relevant. I'm going to append it here onto the context window before I feed it into the chat model. And so now the chat model has access to some external information. But at the base, at its core, it's still just retrieval augmented generation. It's still doing this sort of similarity search where I have a sort of sentence level embedding, which is going to represent the behavior of this, the meaning of this, and then I'm going to compare it against my text. All right, so next time we're going to dive into some other concepts, including tool use and other kinds of agent behavior.